when we're talking about radioisotopes and radioactivity, we are always talking about a large nucleus becoming smaller through decay. And we are going to spend today looking at how do we quantify the rate at which different radioisotopes decay. So the half-life is the term we're going to use when we're talking about the amount of time it takes or the rate of our decay. So a half-life is defined as the time required for half of a sample to decay. So if I have a sample that is 100 grams, then once it reaches 50 grams, however much time has passed, that would be my half-life. So that's the way that science has decided to quantify the rate of decay, the half-life. Every particular isotope has its own half-life. So we have two different methods we're going to look at. First, we're going to do the table method and then the equation method. And both of them will give us the same answer. So on the backside, when you actually do the problems, you can choose which method you like better. I do have the table in there for you to use, but you don't have to use it if you'd prefer to use the equation. But either one is fine. So here's our example. Cesium-137 has a half-life of 30 years. That means after 30 years, half of our sample is going to have been decayed. If 1 milligram of cesium-137 disintegrates over a period of 90 years, how many milligrams of cesium-137 would remain? Before we actually do this problem, I want you to just think through 90 years. If a half-life is 30 years, how many half-lives are going to pass? Well, 30 is once. Add 30 and we get to 60, that's 2 half-lives. Add 30 more and we get to 90, there's 3 half-lives. So over the course of this particular problem, we're going to go through 3 half-lives. The table method helps us visualize what's going to be happening. So when you start out, it's always important to put 0 half-lives and 0 time passed when you write down the initial amount of the radioisotope. In this case, we have 1 milligram as our starting amount. Now we start to track how many half-lives have passed. So after 1 half-life, this problem tells us it's 30 years. And again, that part depends from problem to problem, depending on the half-life of that specific isotope. After 1 half-life, it's been 30 years. And what happens when we get to a half-life? We divide by 2, or divide this in half. So now we have 0.5 milligrams. So each time we go through this, we're going to divide by 2 because a half-life has passed, so half of the sample has to decay. Second half-life now is another 30 years, so now 60 years have passed. And divide this in half again, we got 0.25 milligrams. We need to stop when we reach 90 years. So let's do another half-life. 3 have passed now with 90 years, 0.125 milligrams. There is our answer. After 90 years, 3 half-lives have passed, 0.125 milligrams will be left. Again, to recap, in the first column, you'll count 0, 1, 2, 3, how many half-lives have passed. In the middle column, you will add however many years, days, minutes, or whatever the problem has defined as a half-life for each of the half-lives you count. And then for each time you go through the amount remaining in this third column, you'll divide by 2 each half-life. 1 to 1/2 to 0.25 to 0.125. Using the equation is more mathematical. If you like to think about just plugging and chugging, then you'll want to use this equation, where A is the amount remaining, A0 is the initial amount, or your starting amount, at 0 time. T is the time passed. and h is the length of a half-life. In this problem, our remaining amount is what we're trying to find. So that's my question mark. My initial amount was 1 milligram. The time passed would be 90 years. That's what they were saying to stop at. And the half-life length is 30 years. This right here is a little equation to help us determine the number of half-lives that have passed. If it asked us that, you could find n number of half-lives by dividing the time that passed over the half-life length. 3 half-lives will have passed because we have 90 years total. 30 years is each half-life, so 90 divided by 30 is 3 half-lives. Just a little equation that can help you think through the half-lives that have taken place. Let's plug in all of our numbers. We're going to be solving for A. Our initial amount is 1 milligram. Then our equation has 0.5. And then we're going to put it to the power of t over h. 90 divided by 30, which is 3. So you could rewrite that. If you think about it, this is the exact same process that we just used in the table. We took our amount and then we divided it by 2, or that's the same as multiplying it by 0.5. 1, 2, 3 times the number of half-lives that took place. This is just showing us that same process in an equation. If you plug this into your calculator, you will get the same answer, 0.125 milligrams. On the problems 1 through 5, or 1 through 5, you can use the table or the equation, whichever method works for you, thinking through the concept of half-life. 1 and 2 are just thinking about half-lives themselves, and then 3, 4, and 5 you are solving, just like we did.